Good morning. I'm Cody Hendrickson, and today we're going to be taking a look at the Squirrel subset of the data manipulation language, aka DML. Let's go ahead and get started. Now, when we're working with DML, the big question we're looking for is what about the data? We want to actually figure out what's going inside the actual structures we've been working with, designing in the DDL side. And so the DML is what's inside that. And we've got what's called CRUD. CRUD is the acronym that's been often used to talk about what we're doing when we're working within a database. And so we have the create, read, update, and delete. Create is the same as what we do when we're talking about inserting. Read is when we select, and we've had a whole bunch of stuff we've already talked about at that. Update is yes, update, and delete is also delete. So we have two that are directly matching, and we have two that don't match, but that's okay. We'll go ahead and take a look at that. The select part of the statement, aka what we're doing when we're reading this, we're going to start with this first because we've covered this a lot in some of our other videos, because a lot of the times, actually, when we're working with databases, this is the vast majority we're actually going to be covering. We're using the select statements all the time. Queries are what we do to find things out. This is how we find information. This is how we extract data. This is what we do all the time as a data analyst, as a computer scientist. When we're talking about working within the data, this is where we do the majority of our work. So this is good stuff. We have our single table queries we start off with very early on. We're select from, or we have function-based queries where we're counting things, getting the averages of things, finding the max, the min, etc., and using the magic power of the group by and the having clauses as well. We have our multi-table joins. We have join on and on and on and on as we go through and do all that fun stuff as well. And we've seen that in some of our other videos as well when we're talking about how to actually do some cool stuff with select. And even nested queries. We have a query inside a query inside a query to do some really cool and very powerful features in evaluating logic. But the select is how we actually get that data out. But that's a whole other video itself, and so we'll talk about that some more another time. We also need to be able to put stuff inside the box. We need to define the spots, define the data. And just like when the Ghostbusters are catching the ghosts using that lovely cool little tool that they invented, we have to actually grab that out of there. It's very important that we actually define what we're talking about when we're using the insert command, because we have to define which things we're inserting into. Now, when I write databases, all of my databases are explicitly defined and all my databases have no options for null. So we really have to spell out every single value all the time. Unfortunately, in the real world, that's not always the case. Now let's go ahead and take a look at the basic structure for that as well. So here we have our syntax. When we're talking about the insert syntax, we have insert into, and then we have our table name. We have our parens aligned vertically because that's the way Hendrickson likes it. And it's columns separated by commas. Now, the order that those columns are in does not matter. That's just the order that I'm working with on this individual query. And so we do have to actually care about what does actually matter is that the columns match the values right below that. So what we see right here inside our values clause right below this is that the matching values goes along with columns, and then separated by and commas are direct matches on that. And of course, ending the statement with our great friend, the semicolon. If we look over on the right-hand side, we see a direct example of that with an actual bit of code. We're using the dot notation over here on the right-hand example, and we're using that dot notation because if we're talking from outside the space, we're using I'm going to talk to the mango fruit database, specifically the cells table. And this would happen because I have, say, for example, a login or an access point that gives me access to a range of databases, and I want to talk to a specific database. And so mangofruit.cells allows me to talk to the mango fruit database, specifically the cells table. When I'm talking about an insert statement, it's really important that I note that I can only insert into exactly one table using MariaDB/MySQL for a statement. So I have that right here, so I'm going to insert this into the cells table. I can have a whole bunch of other clauses after that or statements after that, but I only insert into one table at a time. Again, I have my vertical alignment of my parens, just like my squigs in Java or Swiftland. And then you can see I'm using report code and export to destination code and then date as the columns that I'm going to put inside that cells table. And then the values I'm attaching that using the values keyword, I'm putting 12 into report code, 7 to export destination code, and finally a date value of 2020 April 13th as my date value for that. Now, it's really important when we're talking about our insert syntax that we clearly identify the values we're putting forward to each value. And this is one of the reasons why I like using the vertical alignment explicitly, because I can easily see what's happening. Because unfortunately, as long as the types are the same, Squirrel doesn't care if I put the 7 into the export destination code and the 7 into the report code values. They're both numbers. Cool, I'm good to go. But that would drastically change who's getting which thing and where that's going to. And that'd be a big problem if I'm actually doing some real orders or something, or I'm actually talking about something that matters for the real world. So it's really key that I do not give really bad variable names. I don't want to do like, say, field 1, field 2, field 3, field n, like, say, for example, auto-generated databases could possibly give you. So it's really important you actually name your your fields or your columns that you're working with in your database properly, because we want to actually have a resource that's helpful for you as a user or as other people who are coming and working with that database after you. Because you can't guarantee you will remember the order, and then one of the powerful things about a database is that the column order doesn't actually matter. I can talk to this column, this column, this column, that column, whatever, in any order I want. And so I have to make sure that I use that proper sequence appropriately. So I name things that make sense, and then I use that value to go along with it. And so that's one of the reasons, again, why I use that vertical sequence, so I can easily identify which ones I'm putting for and where they go inside that block. The next one we have are our update and delete sequences. Now this is really important. We have to be careful with these two clauses that we're working with. The lack of specificity leads to some really big problems. The where clause is even more important here in these two statements, update and delete, than in the select query, because the where clause controls how many changes are going to happen. One of the best practices we can use when we're talking about update and delete with our where clause is to use the primary key. Unfortunately, that's not always the case, because sometimes we may not know the primary key, or we're looking for a specific type of value, we're looking for ranges of values, so we really have to make sure we're using the right kind of where. Now, we see this example in the great film Ghostbusters again as well. When Ray is asked for something innocuous, he's trying to think of something, and he comes up with the Stay Puft Marshmallow guy. Now, the Stay Puft Marshmallow guy looks all cute and happy, as you can see in this GIF right here. I'm like, ah. But as we know, when we're watching the Ghostbusters film, the Stay Puft Marshmallow Man is also destroying the city as he walks along through it. And that is something we just can't abide. We can't just innocuously go through and destroy everything as we walk through it. So we really have to make sure we're using a very specific and a very well-defined structure inside our where clause. Otherwise, the good idea of a cute little fluffy Stay Puft Marshmallow Man doesn't actually protect us, because the angrier it gets and starts destroying things is a problem for the real world. So we have to make sure we're having a really good clause about the where, because if we don't, the bad impact of having an angry Stay Puft Marshmallow ghost across the city is the same kind of problem we're going to see inside our database. Specifically, let's take a look at the update query. When we're using an update statement, we want to change specific values inside a row. Now, we can change as many values in that row as we wish, 1 to n, where n is as many as they have to be. We want to make sure we explicitly define all the columns that are affected as we do that actual update query. And if we have more than one column that's affected, we separate those with commas. And it's really important, really drastically important, that if we don't have that where clause, every single will be changed. We have to make sure we watch that. And so we have this nice little clip from Torchwood.
And arming the human race against the future. The 21st century is when everything changes. And you've got to be ready.
So just like Captain Jack, we have to make sure we recognize that we have to be ready for this. We have to make sure we explicitly call those clauses out and make sure we update it properly. Otherwise, we're going to change everything. And wiping out entire piles of data with, say, for example, bad default values, bad idea. So we have the actual syntax right here inside an update query. So we have update table, and then inside the update table, for that we have the set, and we assign values separated by commas. So I have column equals value, additional equals values as needed. So again, that last one, of course, doesn't have a comma. And then where, and that's where we identify how we restrict which values are going to happen. A direct example of that over here on the right. So I'm going to update mangafruit.exports, again using the dot notation to talk explicitly to the exports table inside the mangafruit database. I'm going to set the export destination name to romchick when export destination code is 2. So that'll affect exactly one value, because the export destination code is the primary key for the exports table. I'm going to update the name column of that, export destination name, to be romchick for that inside the exports table. So that's what I'm doing. That'll affect exactly one column, because that's only going to be doing one thing. If I wanted to affect all of them, if I left off that where clause, then everybody would have the export destination name of romchick. Now, although this romchick is amazing, setting every single export destination name to be that would cause a problem for our exports table, and we don't want to make sure we confuse everybody else. So we want to make sure we always have a good where clause so we can identify exactly who we're affecting. And that's where that becomes very important. Again, delete has the same basic impact we have with the update clause. We have to remove rows from a table. And when we do this, we need to make sure we specify the table. But we also need to remember that this does not delete column or information. So we can't just simply take out entire columns or a column worth of values, because again, Henriksen hates null. He's not going to allow you to have a nullable field inside his databases. No, not going to happen. This takes out entire rows of information. And again, if you do not have a where clause, instead of every row being updated, every row is deleted. And if we wanted to run truncate, we'd run truncate. No, we want to delete specific values. Now, sometimes you want to delete ranges of things. That's great and all. But you have to have a where clause to make sure that happens properly. And so we have the amazing John Wick, Keanu Reeves demo right here. He's going to kill them all. So we have to make sure we don't just do that. We have to only kill the things we need to kill inside the actual database, because only the values we care about that we want to get rid of are the ones we want to get rid of. We're not trying to go and get rid of everything. We're only getting rid of the ones we really need to. And so that's something we really want to keep in mind when we're talking about the DML statement of the delete clause. Our syntax on delete is ridiculously easy, and this is one of the reasons also why we have to be very careful when we're using it. Delete from, table, where, column is value. And again, that where clause can be as complex as you need to. It can have as many ands or ors or whatever as you want, but you have to make sure that delete sequence is in there right there for that. And so in this case, we have delete from cell statements, not using the dot notation this time, where quantity equals 2221. That'll take out, on my example we did for the database in class, exactly one value out of my cell statements, because only one cell statement had that much quantity sold. And that's where we can do a little example for that. So that's a quick little example of how we can do some of the DML statements, specifically how we can work with the update, the delete, and the insert, so we can see the basic idea of that. We'll talk more examples about that. Check out some of the other videos, and have a great day.